but we'll just give it a few more minutes here and then go ahead and get started. And today we'll be covering Chiad Edge, the edge component of Chameleon. So this is a good opportunity to learn more about that. And Soufiane is our lead engineer. So we have very fortunate today to be joined by someone who has a lot of insight into using that part of the testbed.
My AirPods. Can everybody hear me?
Yep,
Yep.
it's better.
Is that a lot better? Cool. Awesome. And we can, there we go. I can at least. Okay. Sweet. So can everybody also see my screen? Which screen am I sharing now? So
the slides. Yeah, I see your presentation.
Okay, that looks like the right screen. Okay, well, let's start. Hi, everybody. Welcome to this tutorial on Chiad Edge. Chiad Edge is our edge testbed. Essentially, it's a collection of edge devices that we have built an infrastructure for to provide both access for workload orchestration, access for in-band management, such as being able to remotely power on and power off the devices, but also the ability to both use our own devices, but also enroll your own devices, which is our one of our main features, where we allow people to enroll their own little edge devices like Raspberry Pis into Chiad Edge. Instead of having a lot of text, I just wanted to show you guys some pictures of what Chiad Edge looks like, really. These are pictures from our Internet of Things lab at U Chicago, where most of our Chiad Edge devices are currently hosted. So these are the ones that we provide in the testbed. We have about, I would say about 20 Raspberry Pis, maybe about 20 Jetson Nanos, and some more other devices. Here you'll see that we have, this is, I think, the Raspberry Pis. These are the Jetson Nanos, and these are some special little devices. This one, for example, has peripherals on it. It has a camera. This was actually at my house in front of me right now, and it has this this little sense hat with a bunch of sensors. The way I'm going to structure this tutorial is I'm just going to go through a variety of topics. I don't have any specific slides for them, but instead I will be demoing everything live. The first topic that I wanted to explore are the first two topics are authentication and hardware discovery / GUI. So let's get acquainted a little bit with Chiad Edge and how to use it. First things first is you have to be logged in onto the Chameleon webpage portal. And then you go over to experiment and you go over to Chiad Edge and you should land at this page right here, which contains a bunch of really handy links on how to navigate Chiad Edge. The first thing I want to show you guys is the GUI, which at first is not super important to know. I think we have multiple interfaces for accessing your Chiad Edge devices, but the GUI is one of them. If you click on GUI right here, you should land about over here. So this is what the GUI looks like. It looks like just about the same as our bare metal GUI, except instead of accessing the compute tab, you'll access the container tab and then go over to your containers. Here you can see your containers that are running. If you go over to, if we jump back to here, to our main page, I also wanted to show you, before I show you guys how to reserve a device, I wanted to show you how to know what kind of hardware we have on Chiad Edge. For that, you go over to the device resource browser over here on this link, which should display this page. This page has a bit of information about what each type of device that we have. We have Raspberry Pis, NVIDIA Jetson Nanos, some Jetson Xavier NXs, and some other devices. But most importantly, to see an actual updated table of the latest up-to-date hardware information, you go over to the hardware discovery table over here, which looks a little bit simplistic right now. It is essentially a list of all the devices that are currently hosted on Chiad Edge, the own projects and how many projects are authorized to use it, and some information about the devices such as the type of hardware, the UUID, and the device profiles, which indicate what peripherals are supported by this device. So yeah, so this is just an overall, a general overview of the type of devices we have and all of them updated. But to actually make a reservation, we need to check out what devices are available and how we can reserve them. So the first tool that you have at your disposition in order to make a reservation, we're going to move on to this section. The first tool that you have is the same as our bare metal hardware calendar. You have a device calendar, which you access by going over to the GUI, going over to the leases tab, and then pressing device calendar. The bare metal one, I think, shows host calendar. This one's device. And then you will see a very familiar interface where you can check out which devices are available. White over here means that they are available and no lease on them. I currently have a lease on a few devices, including this one, this one, this one, and this one. So all the other devices are available except for the gray ones, which I think are offline. So this is the tool that you would use to figure out if a device is available. Okay, once we know which device we want, I already have a few of them. We might want to get started with actually reserving a device on Jounaid and possibly running some stuff. In this section, I will run you through a few things. So the first thing I'll run you through is our basic Jounaid tutorial, which I think should be a very good starting ground for any sort of experimentation on Jounaid. This basics tutorial is essentially going to contain information and instructions as well as code on how to reserve a device, how to start a container on a device, and how to access your container. For that, we'll go over back to Portal. So over here, we'll just go over to the Experiment tab and press on Trophy. If you press over here, you'll be able to access this page right here, which shows a bunch of artifacts. These are tutorials. All this stuff is accessible to you guys already. The tutorial we'll be exploring today is the Jounaid tutorial, which is an introduction to the Edge platform. I already have it open somewhere, but if you press on the Jounaid tutorial, you will get a short description of the tutorial as well as what's covered, and you'll get the ability to launch on Chameleon, which will, if you press this button, it will spawn up this interface, Jupyter, which will allow you to access Jounaid through our programmatic interface, which is Python-G. To get started, I went through the cells. This stuff is self-explanatory, so once you actually hop into this tutorial, you'll be able to run everything. There's plenty of instructions. But just to recap what I did, I go through some basic steps. You have to choose your project over here. I am on the Chameleon project. And then you import our libraries for accessing containers. You then move on to reserving an edge device. And here I made a lease for an edge device. As you can see, I made sure that the machine name is the Raspberry Pi. I did not specify a device name because I do not want a specific device, but instead I just want the system to give me 2 available devices. I already ran the cell, which gave me 2 devices. So now that I have my devices and my lease is active, we can actually go check that the lease is active on the Jounaid GUI. To do that, we go over back here to our leases, and then we'll see that I have a lease right here for Raspberry Pi that's active. That means that I have 2 devices that are mine for the next day. After that, we'll go over straight to launching our first container. The recommended approach to launching containers on Jounaid, or the primary approach, should be to launch them through our programmatic interface. So in this Jupyter interface, you have in your disposition a library called Python-Chi container, which contains a very convenient call called create container. So this create container call, essentially what we're going to do here is we're going to start a container. For the container to run, we need to give it an image, which should be a Docker image. This one's a very simple one. It's just a Python slim. We're going to give it a command to start the container with. In this case, in this specific container, we start a web server, so a basic HTTP server. Some other things to note here, we open port 8000 for accessing the actual HTTP server. And then most importantly, we pass in a reservation ID, which means that we give it a link to our lease, essentially. So this is the ID to our device. After running this, which I can start running right now, it'll start requesting a container which means that it's currently down on an image. We can actually go back and forth between the GUI and here. If we go back to the container tab, we'll see that this web server right here is started, has been created. This is our container. We have it running at the moment, but at first, when you first started, it will say creating. Now that we have this container running, the first thing I want to show you guys that the immediate way you can interface with your container is through this console right here. So once you press on this tab, you can go over to the console tab and instantly you're thrown into a familiar interface, which is in this case, a shell. We're inside our container. So if I make a specific command like ls, I think we're not exactly in any directory right now, but if I print the working directory, we'll see that we're in the var www HTML, which is what we specified here. That means that this container is running insane. We can move on to other steps of the tutorial. After you created a container, you probably want to interact with it. We provide a variety of tools, except from this. You can, of course, always use this to interact with your container, this console, but other tools are available in a programmatic interface. The first one is the ability to execute commands. So right here, I can simply use the container.execute call to execute a command. Here I'm just, again, ls into the directory, in which case, if I run it, it'll just say, that there's nothing in the directory. The next thing we can do is we want to actually access this web server. So Jounaid devices run on private IPs. Of course, they run behind our own virtual private network. So in order to be able to access them via the network, you need to assign a public IP or a floating IP. Similar to how you would assign a floating IP to a bare metal node, you would do the exact same thing for a Jounaid node. We have a very convenient, convenient function to do that in our container utility, which is called associate floating IP. You can also do this the same way you would do it for a bare metal node through the GUI. Here, I will just go ahead and run this cell, which will give us a floating IP. This one will associate a IP. It's taken. So it's given us the 0.138 address. Then after that, once we have this IP, we can start actually uploading things into a web server. So for that, we also have some convenient calls such as container.upload. In here, I will simply upload a very simple little page that I have here in my local directory. I'm going to upload this exact file, hello.html, to my container. So to do that, I'll go back here and I will I'll execute the cell, which will essentially upload the file hello.html, as well as upload the entire directory, the web server directory. So once I run that, I also run an execute to make sure that my file has been uploaded successfully. The execute command is in ls, and as you can see here, it returns the results, files uploaded, and then I can see the return output of the ls command, which shows me that I've uploaded both hello.html as well as my web server. So immediately what we can do is we can actually check if this web server is working correctly. We have a floating IP, so we can access it from our browser. I'm going to go ahead and press on this, and it should show me hello from Jounaid. So this is us accessing the device through a floating IP. The device is hosting a web server that we've launched through a container. So virtually we could actually upload any HTML page here and it would show up here. So yeah, this is one way of interacting with a device and having another ability to interact with it via your web interface if you associate a floating IP to it. Okay, that's done. The next part is that I will show you guys how to download something from the device. So here I have a few commands that will execute. I'll explain what they do. Essentially what this will do.
Question.
Yeah, of course.
Are we executing these commands as a root, or we are some user on it?
So the container that we launched here is running as root within the container. Right here in this interface, in the Jupyter interface, I'm running in, we provide, this interface is hosted on a completely different service. So right here, every cell that you run on this specific notebook doesn't run on the container. It just sends commands to the container. You essentially use the container utility container.execute to send commands to your container. And yes, they run as root inside your container. Did I answer your question?
Yeah, I was thinking about the container execute only, like container execute executes as root.
Container.execute executes as root, indeed. It's essentially the same thing if you've ever used Kubernetes, if you've used Kubernetes exec or Docker exec.
Yeah.
It's the same exact thing. We're using that WebSocket API to send commands.
Oh, okay.
So right here, like what I will do is I will essentially just create a file inside of the container, and then I will download it from the container. I will create this file via a bunch of commands here. So this one will create a file called todownload.txt and a directory that's called todownload. And I'm going to download both the file itself and the directory using our container.download. If I do that over here and I run this command, you will see over here that some new stuff will pop up. The first thing that we downloaded is the todownload.txt file, which will pop up right here in a minute. Right here. Okay. So the first thing that popped up seconds ago is this one. So, hey, you just downloaded me. That is the file. And then we also downloaded a directory just to show that this command is also able to download directory. So I'm going into it and then I press this, and this specific file says, hello, I was inside the directory. So this is just a way in which you can interact. The container.download and upload methods are meant for small files. So we would recommend, if you have to upload data sets or download data sets, always use a internet service such as I don't know, AWS S3 or Swift or anything else to host large files. This is not meant to be downloaded in gigabytes. Plus, these devices are relatively limited in resources, so it's likely not to be possible. Okay, so that was a bit of a rundown. To recap what we did, we launched a container on a device, and then it was a container that contained a web server, so that was within the Docker file of the image. The next thing we did is we associated a floating IP to the container, and then we uploaded some files, notably here the hello.html file. And once we uploaded that to our web server, we used the floating IP to access that, like this. Okay, so that's the basics tutorial. I wanted to, do you guys have any questions about the basics before I move on to other things?
One question is regarding the floating IP. Are you like creating for the floating IP, or is just you have a pool and you just pick one randomly and assign it to the pod?
Yeah, that's a good question. So similar to the bare metal, to our bare metal sites, we have both a pool of ad hoc floating IPs that you can pull from every time you press associate floating IP, but you can also reserve your own floating IP through the leases tab and associate that one as well. I can demonstrate that really quick. So I can show you already that when we actually send that command, if we go over here to the network tab and then floating IPs, you will see that we have a few floating IPs here. I think this is the 138 was the one that I reserved, and it was automatically mapped to the private IP of our container. This is the IP that signifies our container.
Okay.
Yeah, so that's
So,
how it works. It works the same way as bare metal.
oh, okay. Yeah, because in bare metal, I think you need to first like lease a floating IP and then use it.
Yes, you're right. So that really depends on whether there are ad hoc floating IPs available. So we have a pool of free floating IPs that you could use without reservations, but
Okay.
sometimes with elevated usage on sites, they kind of run out. I think on Chillage we have about 100. So if 100 people are using floating IPs for their containers, if there's 100 containers and you use up all the available floating IPs, then you're going to need to make a reservation for more.
Sure. Thank you.
Mm-hmm. Going back to our topics, the next thing I wanted to show you guys is just a little bit of a run over of our advanced capabilities. I showed you guys the basics, but we can actually move on to some very interesting stuff. The first thing I'm going to be demonstrating is within that same notebook that I opened, which was the Chiadage tutorial. Within this same notebook, we have an example showing how to use an NVIDIA Jetson and how to use it to start a GPU workload. So I currently move on to this tab. You can access it from here, NVIDIA GPU workloads. What will essentially be shown here is how we will run a neural network using a NVIDIA Jetson device, which has a GPU. So one important thing, so we do the same exact steps, except this time we request a Jetson Nano instead of a Raspberry Pi. So we make a reservation for exactly one Jetson Nano, and we get it for about a day. Once we have our device, we move on to the create container call. In this here, there are a few differences. So the first difference is obviously you need a different image. Right here, I'm feeding a L4T PyTorch. This is a PyTorch image for our CUDA devices. We have extensive documentation that I will show you later how to access about how to use these devices. But yeah, I'm essentially going to start a container image that contains PyTorch. Another thing that's important is that when you start in NVIDIA or a GPU workload and you have an NVIDIA device, you have to specify the runtime NVIDIA keyword over here, because this keyword essentially tells us, it tells Edge to spawn a container with NVIDIA runtime instead of a regular runtime. And the NVIDIA runtime will actually be able to load in GPU capabilities such as CUDA and various things that need to be mounted in order for the GPU to work. So this keyword is quite important. This will only work on the Jetson devices. It will not work on Raspberry Pis, which do not have GPUs that you can access. So once we actually start this, I can actually just start this container as well. I already have the device. I believe the image is already downloaded on the device, but if you do lease the new device, it'll take a while because this image is about 800 megabytes. Once this container starts, I can show you guys how we're going to execute this right here, which is a little script that I made for a very simple neural network. And it's just going to recognize some digits, some handwritten digits. So if we go back here, again, once you start a container here, I really recommend using a combination of both the programmatic interface, which is Jupyter interface, and the GUI, because you can always go back here, go to containers, and then see your containers over here. We can actually quickly see that our container here, okay, so there's sometimes there's some intermittent failures. This one's quite well known. The container could not be found. Really, all I recommend here is just to restart the call. So because sometimes stuff happens and it just doesn't start your container. But yeah, right now the call has started and we can see that the container was immediately deleted, which means that there was an issue with it. So we're just gonna delete it over here within the interface, and we're gonna go back over to our notebook and start it again. This can be a process sometimes. There are some unchecked behavior sometimes, but ultimately you will always get an error message. And if you don't get an error message within Jupyter, you can always go to the GUI, which will then show you something more concrete. Okay, so this time the container actually started and it's running now. Once again, we can always just go over here and just check that this container is sane. Okay, cool. Going back here, so now the container is running and it looks like it's running with an NVIDIA runtime. So the next thing I'm going to do is I'm actually going to upload this simple neural network to the home directory inside the container, this cell. And once it's uploaded, I'm going to send a simple command to start executing the file, which is Python 3 simple nm. So we can probably just start it now. This should not take more than 10 seconds. And currently it is starting the code inside. And this showcases a example of how you would start a GPU workload on one of our containers. As we wait for it, I will, should be done in a second. Once again, we are sending commands to the container. We're not executing them within the container. If you want to do that, always use the web console. Okay, so we have some output here. It tried to download some data sets first. Looks fine. And then the next thing it did is extracted the data sets and started training the neural network. We can see that the loss is going down, so all is good. And given that it was using PyTorch, which won't work without CUDA, it means that it did use the GPU and worked successfully. That's how you would use an NVIDIA GPU on one of our NVIDIA Jetson devices. Going back to our topics, does anybody have any questions about the NVIDIA GPU stuff before I move on? Okay, see that we have some new people. Welcome. So back to our topics, the next thing I want to demo is another advanced capability, which is the ability to use peripherals. As I showed you guys in this image right here, I do have a device on my place that is equipped with a camera and a sensor right here. So I'll do the fun one and I'll just show you guys how to use the camera. Yeah, so I think over here, once again, you go over the sharing portal, artifacts, and we have a full tutorial on how to use the camera. This one is not included in this one, so this one's separate. You would have to go over here, press on Edge camera peripheral tutorial. And yeah, this essentially a description of what the tutorial contains. Before I move on to this tutorial, I just want to say a few words about peripherals in general. So the main thing that people want to do with edge devices once they have them is they probably want the edge devices to interact with their environment, whether it is to sense or to actuate. You can add a variety of peripherals, including cameras, sensors. People often build various stuff with their Raspberry Pis. Some people build temperature sensors, thermostats, and we have, of course, added this capability into our testbed to allow researchers to investigate various different peripherals. The process of adding peripherals to Edge is a little bit more complex than the very basic workload I showed you guys. There is extensive documentation that you can find on our Edge page on peripherals and how to enable them in case you want to add your own custom peripheral. But for now, I'll show you guys an example of a peripheral that is already added, which is the camera. Again, same structure. We start by choosing a project and we make a lease for a device. In this case, I'm going to make a lease for a specific device because the specific device that has the camera is at my place. You can actually see which devices have peripherals through the hardware discovery page. And this is where this comes in useful, is that you can see right here that some devices have device profiles, and those profiles will indicate which peripherals are hooked into the device and supported by the device. Okay, we have our device, SJRPI42, and the next thing we do, simple, we follow the same exact workflow. We will start a container. In this case, the container will contain a little bit more than the others that we've started. This one will actually contain a few libraries that are used to drive the camera. We provide, in this case, we provided a image for the Pi camera. The Docker file is also right here for people to look at. We have a bunch of libraries in here, including libcamera, which is the main driver library for the camera, as well as RPI cam apps, which are the applications that we use to take pictures. So in this case, one notable difference from the other times we create containers, this one has a device and or a peripheral. And in order to enable a peripheral, you do need to pass in a few things behind the scenes, including /dev devices and other things. For that, we've created device profiles, which are essentially indications that you want to use a peripheral. The same way that runtime NVIDIA was an indication that you wanted to load a GPU environment, this one is an indication that you want to load a camera environment. So the device profile here to include is Pi camera. We have a few preset ones, but this one is the one you would use here. So we can go ahead and start this container with Pi camera, and it'll start requesting our container. Once again, go back to the GUI, go back to containers, and we can see what's happening. Right here, our Pi camera container is creating, we can see, and it is running. So now that it's running, the first thing that I will say is that we can always just do a sanity check. Is this alive? Looks like it. So if we go back here, we're going to issue a very simple command. We're going to be like, okay, how about we capture a picture? So this command is using the RPI cam still utility, which is, again, installed into the image that we loaded onto this container. And with this command, it'll essentially take a image that's 1080p, 1920 by 1080, and we'll attempt to rotate it. So I will go ahead and execute this, and we're going to have to wait a little bit of time for it to do that. Okay, cool. So that's already done. It spits out a bunch of output, but the most important one is that still capture image received. That means that an image has been captured. So now that this image has been captured, it is currently on the container. I'll show you guys another way of checking out this image. We can just go back to the GUI right here and just ls, and we'll see right here that the image has been captured. If we do this, we can see that it's about 3.1 megabytes. Back here, what we can do to view this image now is we can just download it. So again, we use the chi container download call to get the image from the home directory inside the container. We wait a little bit. It takes a while for bigger files to download, and of course a while for them to show up on here. But we can see that the image has showed up here. And if we look over here, we can see that the image was taken. This is my desk, and it shows two things. It shows a little edge device right here and a hello chameleon. So that's an example of a picture that was taken using the camera that's sitting in front of me right now. So yeah, peripherals, the most important thing to remember is that device profiles are absolutely essential. Only peripherals that have device profiles are supported. We have various ways for people to be able to contribute their own device profiles as well as peripheral support that we detail fully in detail in our documentation for peripherals. So if you are interested in enrolling your own device, which I will show in a minute, and enrolling and adding a peripheral to it, you just visit our documentation for peripherals, and you can have a bunch of steps on how you would be able to enable your own peripheral. Okay, back to topics. So now I've showed a few advanced workloads and capabilities of Chi@Edge. That should give you an idea of what you can do. The world is your oyster. If you have containers, you can bring any image you want. Just create a Docker file, build it, upload it to something like Docker Hub or private registry, and then you can launch a container on Chi@Edge devices using our interface. Any questions about the stuff that I just went over?
Yeah, can you go over the network map of what you just went over from the hardware to the container to the Pi itself?
Sure. So if I understand your question right, you're asking to go over the sequence of where does the information go through and which network links does it take to reach the devices.
And which devices, yeah.
Okay, so starting from the very start right here, let's call this our interface. This Jupyter interface is running on our system called Trovy. So this is essentially running in a host somewhere, and it's providing you with this interface. So this is authenticated automatically through your account. So consider this as code that could run on right here on Trovy, or it could also run on your laptop. All you would have to do is just download this notebook, authenticate into the OpenStack command line, and then you'll be able to issue these commands through the Python library. What we do here, every time we issue a command here inside of here, we're sending commands to two different places. One is the Chi@Edge API, which is for making stuff such as leases and reserving devices. And the other calls we are sending are calls that we are sending to our backend, which hosts our container orchestration service. We use Kubernetes behind the scenes. So every time you make a create container call, it sends it to the Chi@Edge API. And then the Chi@Edge API sends a call to Kubernetes, and then Kubernetes will start your container onto your edge device. That's about how it works. Now, when you communicate with the edge device, if you send over a command such as execute, download, upload, you're essentially using the same things as Docker copy and Docker exec. So you're essentially using the equivalence in Kubernetes. Every time you send an execute, you're sending an exec, which is through WebSockets. So that's again going through the Chiedage API and going straight to Kubernetes, and then return to you through the same link. Every time you now the other thing is, once you have a floating IP, once you bind the floating IP to your device, you're officially going through our WireGuard link. So each device on Chiedage is configured in a hub and spoke configuration, where the hub is our control plane that is hosted in our Texas site. And every time a command is sent, such as, let's see, for example, the first thing that I was looking at was that website. So when you press this and you get this page right here, you're essentially sending a request all the way to our control plane, which is also, I referred to previously as the Chiedage API in Texas. And then our control plane is sending this request through a WireGuard link to the device specifically. And then the device is returning that request through our control plane in Texas straight to your computer. Those are the few confusing different network links that we use to access these devices. Did I answer your question, or?
Kind of. I mean, it sounds like basically there's that one stage, which is essentially the floating IP, which is the public IP address, which is what's allowing the camera, which is sitting in your home, which is not on the network, on the Chameleon network, to talk to the Chameleon network. Did I get that right?
So the floating IP is actually not allowing the camera. Once you enroll a Chiedage device onto Chiedage, it gets we essentially spawn a WireGuard link on it, and it is networked to our control plane through a virtual private network. So it's not going through the public IP. The public IP we only use to access containers. So we essentially bind a public IP to a container in order to be able to make an HTTP request like this. But on the camera side, yeah.
That sort of answers my question, which is that the whatever device you're going to have physically in front of you, or I'm going to have physically in front of me, has to go through that WireGuard link, which means it has to be running a POSIX operating system so that it can actually do that.
Yes, yeah, of course. I mean, so the containers
not necessarily,
that you run,
of course. I mean, a lot of the stuff that I mean, most of the edge stuff I do is on microcontrollers. So I'm used to doing this without an operating system. So what I'm trying to sort of think through is how I'm going to essentially get the VPN physically into my space so all those microcontrollers can connect. And the answer is I'm going to have to set up something with an operating system to do it, right?
Yeah, so I could answer that a little bit more. So Chiedage does have some constraints. One of them is that we don't provide bare metal access to the devices. So I was actually going to go through that next. The process of enrolling your own device does involve baking an image into your device, which is a specific OS image. We use Balena behind the scenes, so you need to use a Balena OS image that automatically enrolls your device onto our fleet. And that's, as far as I know, it's a Linux image. It's quite restrictive because once you have that running, you can only run containers on that OS. It's a very bare bones OS that only runs containers. The way we set up the infrastructure behind the scenes is that once we have that OS running on a device, we run Kubernetes, WireGuard, and our own services. And we only allow users to be able to schedule containers through Kubernetes on the devices.
Okay.
Yeah, so that does disqualify any sort of low-level microcontroller work on our edge devices. Everything has to be running through a container, which is both in a way simple, but also complicates more complex workloads.
We have different definitions of simple, but go on.
Yeah. The next thing is we're going to enroll a device into Chiedage, or I'm just going to show you how you would do that. So if you have your own device and want to enroll it, you need to use our Python Chiedage client, which you can install using pip. So you just run this command, pip install Python Chiedage. And once you have this client, you need to authenticate. So to authenticate to it, I don't know if you guys have already gotten this tutorial, but to authenticate to it, you need a application credential, which you can get through the Jounaid API GUI. So if you go over to the GUI here and then go over to identity and then application credentials and you're logged into your project, you can create an application credential over here. And once created, you can download an OpenRC file and source it, just like I'm going to source this one. So the one I have currently is the application credential for the Chameleon project, which I'm authenticated into here. Once I source this file, I'm officially authenticated into Chameleon. So to access the Python Jounaid client, you run a command Jounaid, and then let's say the first thing I want to do is just list my devices. This account does contain all the Jounaid devices. So this command just showed me all the devices that I showed you guys as part of hardware discovery. All of them are enrolled here. So to enroll a device into here, you would first need to go to our documentation page, download one of the OS images that we provide for the specific device type that you are trying to enroll. If you try to enroll a device type that we don't currently support, you can simply contact us and we can, if those devices are deriving from a Raspberry Pi or a Jetson Nano, we can probably make it work. But let's say you're trying to enroll a Raspberry Pi. You would first register your device through a variety of, through a call like this. Yeah, so you would register your device, you'd input a few things such as your contact email, application credential ID, and secret, your machine name, and your machine type. Once you run this, you will essentially have the device registered to our system. The next thing is to obviously have a OS image for it. So once you download one of the OS images that we have on our documentation, you have to bake it, which is the process of uploading, or more like modifying, the OS image to include a configuration file that we specifically configure for the device to be able to join our fleet and enter our virtual private network and enroll into Jounaid. So the bake call is simple. It's essentially you specify an image. I have one downloaded, which is the this Raspberry Pi 4 image, and you then specify the unique ID of your device. In this case, I think I was flashing this device, the SJRPI402, which the ID for is here. Once you bake your image, you will essentially have the image ready. What you can do is use any sort of flashing tool to flash that image into an SD card and then insert it into your device. Now, once you boot your device and connect it to the network, it'll officially pop up on Jounaid, and you will be able to see it over here. So it'll officially pop up as one of the devices on the device calendar, and you'll be able to reserve it. And you'll also be able to specify whether you want other people to reserve it or simply your project, and be able to run your own workloads on it. That's the last part of our tutorial. With that, the tutorial is concluded. I did want to just point you guys to the documentation, which can be accessed here. If we go back over to the Jounaid page, you can see a link to our documentation over here, which if opened will open up this documentation right here. And here it does a few things. There's documentation about how to enroll a device. There's documentation about peripherals and device profiles and how to add your own. Documentation about the NVIDIA devices and how to use them, or how to use GPUs, and the various getting started guides, how to join a project, start, essentially everything I've said in this tutorial, but in more in-depth details and information. With that, that concludes the list of topics that I wanted to explore today. So I will be taking questions for the next 10 minutes.
Wonderful. Thank you, Soufiane.
Thank you.
That was great. As Soufiane mentioned, there's a lot of tutorial. I mean, everything he was going through today is all on Trovy, which if you're not familiar with Trovy, is a very useful interface that we provide on the testbed. So all of these examples that he was going through today are things that you can just walk through yourself as well. Assuming you have a active allocation. So again, thank you, Soufiane. If anyone has questions, please feel free to jump in. We will have a short kind of open office hours at 3 p.m. today, where another engineer from the Chameleon testbed will also be available to answer questions and just generally kind of any questions you might have about using the testbed, and if you have specific questions about your projects and whether or not, how you can do different things on the testbed for your project specifically, those are all appropriate topics for the office hours. So yeah, any other questions for Soufiane or for me? Saeed, go ahead.
Hello.
Hi.
We're not able to hear you, Saeed.
Can you hear me now?
Oh.
Yes, your microphone's a little loud.
Oh, okay. How
Yeah, we
is
can
it
definitely hear
better?
Oh, that's much better, yeah.
Yeah,
Much
okay,
better.
sorry. Hello, thank you for the presentation. So just quick question about how we can access the Jetsons and Raspberry Pis. Currently it's through the Kubernetes, and I'm using it extensively actually these days. But is there any roadmap to have kind of a bare metal access to the devices in the future? So without the containers, just out of curiosity, if something to be considered in the future.
Yeah, we do get this question quite often. It's always been a point of it's an interesting question. So when we originally designed Jounaid, we made a few trade-offs. In this case, because we're essentially dealing with little edge hardware that only has one network interface and various other things, it's not exactly like traditional bare metal servers. We don't have a bunch of ways of how to manage the device, how to provide, for example, out-of-band management is not possible. And so we had to really think about how we could provide these devices to users while guaranteeing some important things such as tenant isolation, resource isolation, and security and various other things. And part of this trade-off was this architecture of having to only allow the runtime of containers. So do we have a roadmap for bare metal access to Jounaid devices? We don't currently have that in our roadmap, but it's always something that we continuously discuss and explore. It would definitely require a bit of architecture modifications that are not within the scope of the current near future roadmap, but it's always something we're exploring.
Yeah, great. Thank you for the answer. So, one specific problem or challenge, I would say, I had recently, and I was in contact with you regarding it, was that the so I was using some images that, at least based on what their author said, should have been able to run on Jetson Nanos, but since they were large image sizes, when they were spawning up on the device, probably if it was the same libraries, where if I was to use the same libraries on a bare metal and install them, it would have worked. But since they were going as an image, yeah, the image was not working, and I think it reached to some out of memory or something. You told me in the Kubernetes cluster. So yeah, that was one specific problem, and the CUDA image that currently we have and we use on Chameleon is the one problem with that was it's using an old Python version. The newer version, just the next version after that, is suddenly like the size goes from 800 megabytes to 5 gigs, and yeah, it's I wasn't able to use the next version. So yeah, that was some one challenge I faced. But yeah, I understand it's a challenging task to give access, bare metal access to devices.
Yeah. Yeah, thank you for the question. I think I'm going to summarize a little bit and kind of try to make it useful for everybody else. I know exactly what we're talking about, and we can talk into the details a little bit more on other channels. But essentially, one problem that Saeed just mentioned is that if you try to run images that are very large, such as a 5 gigabyte image, you might run into problems with some of our devices that have less memory. Notably, our Jetson Nanos only have about 28 gigabytes of eMMC memory. On top of that, about 10 of those gigabytes are used by the OS and the various services we run. So essentially, at the end, you end up with about 15 gigabytes of working memory. The image compressed was 5 gigabytes, but uncompressed was 10 gigabytes. That's a little too large, as when you start running that image, Kubernetes starts downloading it, and then it's like, oh, this is only leaving me with like 5 gigs of memory at the end, and it kills your image. It kills your container. So for a rule of thumb in general, if you are developing a container image to run on Chiat Edge, always develop for the least amount of dependencies that you need in the image, as these are edge devices with a very limited amount of resources. Again, Jetson Nanos only have about 28 gigs of memory. We do have some other devices that have more memory. I know the Raspberry Pis have various sizes, I think 32 gig SD cards and various others. But again, the memory is a very, very big bottleneck on these devices, or not the memory, but the disk size specifically. So that's one issue. Another issue, the Jetson Nanos have some very specific requirements. Because these devices are running not regular Linux, but rather Linux for Tegra, which is NVIDIA's platform for Linux that runs on their Tegra chip devices, which are the mobile devices. So that platform is quite different from a regular desktop version of Linux, because it only supports a very limited subset of things that NVIDIA said it would support. So for example, on these specific Jetson Nanos, on the current OS version that we're on, the only supported CUDA version is 10.2. So if you try to run any image with another CUDA version, it will not work. All of this stuff is mentioned inside of our documentation. If you just head over to our frequently asked questions and you go over to how to run a command, you will see that the images and software that is compatible with the current L4T, which is 32.7.3 that is running on our devices. You can see this also on our hardware discovery page. So yeah, all your software that wants to use NVIDIA GPUs has to be compatible with the current version of Linux that is running on these devices. Those are the two main contention points. Overall, these devices are very limited in resources and also in capability, mainly due to platform locks and various other things. So the help desk is always open. So if you run into any problem orchestrating your workload on Chiat Edge, feel free to contact our help desk. There are multiple people working around the clock to answer requests on it, and tickets should usually be answered within 1 business day, and you will be able to get some more specific and more personalized help on your workloads. But yeah, thank you, Saeed, for bringing that up. I'm glad that you are using our devices quite extensively.
Yeah, thank you for also the help through the help desk and the presentation.
Of course. Okay, so I'll just ask one more time. Any more questions before I close this off and hop off? Okay, then if we don't have any more questions, I conclude this tutorial. Thank you all for attending, and I hope that you all get to use our edge devices. Currently, the utilization has gone down this week, so a lot of devices are available. I encourage everybody to at least try our Chia Edge Basics tutorial and try to run your own web server, your own MQTT deployment, or your own neural network, whatever works for you guys. And yeah, happy tinkering on Chia Edge.